Splitting the case isn't that hard. I do have to pull the gear off here though before I can split it. But let's see, where's that socket at? Right here. Nope, next one out. 15/16. Now the bearing, the crank will come out of the bearing now. Couldn't take it apart, couldn't take that off. Just one of those deals you got to deal with. I'm not using stock bearings, so things are a little bit different how they're done. Okay, that we don't need. I need my 12-point socket over here for the tranny. I don't use studs over here in my transmission. I use 12-point aircraft bolts. The other thing you're going to see is I got a K-model cast iron motor mount on there in here. So originally I ran this bike, the transmission let go. Well, actually the tranny didn't let go, the case let go. So the whole top of the transmission came out like this whole chunk. The whole thing just pulled right out. The main shaft was still in here, pulled up on the main shaft. And I took off from the back of the truck and it come back, and it dumped all the oil on the ground. It was making a lot of noise. It had absolutely no damage in the transmission, but the case had a big corner missing out of it. So this whole corner just went boom, like that. So the stock motor mount only pulls right here, this. This is a 4-bolt mount off of a K model, an early Sportster, 61 and earlier. And this one goes up here. Now this gets you past the center line where it would break, so it reinforces everything. So it's like having a girdle on your case. Plus this is all very strong, so it ties everything together. Between this, the bigger bearings, and that big trap door, the big cast iron trap door up there, when I break the gear teeth, I don't break cases. I've also upsized the bearings a lot. These bearings hold way more than stock bearings will take. So my abusing driving style doesn't seem to care. So you can still buy these on eBay. They're getting way upwards of $100 a pop these days, but they're still well worth it. Now to put this on a late motor, you have to weld the bosses in here, and you have to slot the hole out in the starter because you have to rotate the starter up a little bit to clear. And you got to shave the bolts down right here because the starter sits right on top of these bolts. So it's not exactly a bolt end, but it definitely ties it together. And I obviously weld a bunch of material in the case here to make it thicker on both sides, so the case now is like that thick. And that also ties it all together. This was an early case. I made it like a late case, like an 84.5 case. They take a seal in here and a different setup, so I just welded this thing all solid. And then I got a big steel insert in here. And do that, and I got a double row self-aligning ball bearing in there, so as the main shaft flexes back and forth, it will not hurt the bearing at all. Same thing on the crank up here. It's got a double row barrel roller, so it's a self-aligning bearing, so it flops around. The Timken on the other side over here is a regular Timken, but I run it with a lot of end play in it, like 20 thousandths end play or better. I've run as much as 30,000 end play on my crank. It doesn't care. So everything just kind of floats. The crank kind of floats where it wants to be, and the bearings do what they want. They're free to flex. So as this crank flexes back and forth at 8,000 RPM, it doesn't care. The bearings aren't being bound up, so there's no real drag on anything, so nothing really happens. Same deal in the transmission. It flexes around, it doesn't care. And I've had zero issues with any of this stuff being like that since I've done it. So before that, I had all kinds of issues. So. Now you have to modify parts in order to do this. This stuff is not bolt-in simple. It takes lots of machining and welding and other stuff. And no, I'm not going to do it for you. Not worth it. Unless you're me. Dowel's loose, but it won't come out. Fine. All these bolts are longer than stock, so I get maximum thread engagement. That's it from this side, isn't it? One more. You can see I got an inch of thread going in there almost, 7/8 of an inch of thread. So I'm burying that whole bolt in there because I over torque everything. Nothing really moves because it's over torqued a lot. Every now and then you strip one of the bolts out and I just helicoil it. But it's rare. These cases have been through a lot of abuse over the years and they're still hanging. Broken a lot of parts in these cases, including the cases. Alright, that should be everything on the bolt soles. Alright, should pop apart now. So see how the case split? Stock case would never do that. See the main bearing in there? Self-aligning. See how much off? See how much the case is way over here now? That bearing still works just fine like that. It's coming off the end of the race, so you're past the recommended limit, but it's still doing its job. There's 2 rows in there, so it's still working, even with that much misalignment. So that's a lot of misalignment. So it'll still rotate just fine, see? See, it rotates just fine. No drag, see? Even with a bearing like that. So that high RPM, that crank's flexing all over the place. My crank, my bearings don't care. Keeps on running. There you go, see? Double row barrel. Came out of an XR 750, but you can buy these things normal. So the only disadvantage is they kind of bind up when they come out all the way like that. You got to put them back in. You can see how they clearance my case for high lift, like that Beal motor was you looked at earlier. If you look at my Beal videos, see I cut it right into the bearing race. I cut the whole bearing race away there, if you notice. Because this motor here has a 675 lift in it on an iron head. The cam lobe I think is a 460 lift cam lobe. Before the rocker on. There it goes. Yep. Okay, bearing's back in now. Alright, the transmission bearing does the same thing. Okay, I don't think I need a puller to get this apart. Let's see. I think I left this stuff pretty loose on purpose. Nope. It's not going to just fall out right now. So my crank is nice and loose, see? That's on purpose. Gives you that float again. Alright, my luck, as soon as I get to the press, it falls out on the floor. Okay, I'm going to go over here to the press and give it a pressing situation over there on that press. It's not dropping just yet. Okay, support the case. This is not like the old one. Oh, it's tight. It's not a slip fit. Got a pretty good press on it. I don't recall it being that tight. I thought it was loose so I could pull it in and out easy. maybe it's got some of that bearing lockup issues going on. It definitely wasn't loose, that's for sure. It's a heavy ass crank for being only one cylinder. Feels like I'm carrying a big twin crank. I think it's heavy. You know why it's heavy? It's full of lead. Nice and loose, like it's supposed to be. No evidence of distress going on. Hands are full of oil, so there's the rod in there. Got no in play side to side in here. There it is a little bit. There it is. Definitely got a lot of this. There you go. Nice and loose. That's how you want it, nice and loose. So I made up washed aluminum spacers to go in there and take up all the gap. I'm going to go ahead and take this crank apart and make sure the bearings are good. So the reason this crank is so heavy, this is where the stock steel was at. They had a hole in here, so I welded it. And this is lead, filled solid, all lead. You can see how thick the lead is. See, it's this depth here, and it's flush with this, so it's just below flush. So that's all lead. And if you look inside here, it's all lead on both sides of this side too. See, it's full of lead. All in there. Full of lead on everywhere. Everything's full of lead on all four surfaces. You got lead from here to here, 1/4 inch thick, that size, on inside and outside. See, it's all filled full of lead solid. All those undercut areas I filled solid. So this crank is very, very heavy. So, yeah. It's like picking up a big twin crank. Thing's heavy. Very heavy. So you have a nice big heavy crank like this, especially on a single. Every time that thing fires, it spins that sucker around, and it keeps right on going until the next time it fires, which is 2 turns around, and it hits again. And when you dump the clutch on the bike to get moving, it moves. It jumps the bike forward and can get going on the power quicker. So when you do light flyovers in this thing, it just does not want to get off the line. It's a turd. So I don't see any issues with the lead moving around any. You see some light separation right here, but not much. So I got big holes I put all the way through here, threaded holes, and the lead goes through, and it's melted through the whole thing. So the steel's actually encapsulated by the lead. So it's not coming undone. And if I was going to have any separation issues, it would be this, because that's a lot of weight hanging on there, and it's all I got is just big holes in there holding it. So this is all just laying against the metal, and yet there's no separation. Everybody told me, oh, it's going to come apart. Oh, it doesn't work. A little bit sticking up right here. Piece of lead right there. Yeah, it doesn't work all right. It's in my motor. So anyway, there you go. So the bearing doesn't look like there's any issues with it. I don't see no corrosion issues. Don't lose that spacer. So I think I'm going to go ahead and take this apart and make sure this is all. It feels really nice, but. So this is an S&S Supreme rod. Old style ones, back in the day when they're really heavy. And I used to run the fork rod, because I liked having the extra bearing area and support. But it broke. So I was cruising down the road in my bike, and all of a sudden the ass end locked up and started sliding. I was up at Bonneville doing that, so I was sliding about 135 mile an hour and locked up. So that was into that rod. So the rod came unglued, caused a lot of issues with the cases and other things. So, but being a good old ironhead motor, it didn't hurt the head at all. Head made it through just fine. It barely even did anything to the valves. The valves are almost not even tweaked at all. But the damn piston went an extra 3/16 higher up into the head, raising compression up. You can see all the molten aluminum everywhere. See everything's metal sprayed in here. That's all the molten aluminum. It melts pistons all the time. Free metal spraying. So the Timken bearing in here is it's used, but no issues. Feels good. Everybody says you got to run them nice and tight. I am not tight. There's no wear issues. Look like it's wearing evenly. I'm definitely beating a target. Yep, all the way around is wear marks. See absolutely no issues with it. You can see all the grenaded parts been through this thing. It's had lots and lots of pistons go through this motor. Lots of them. I don't see any evidence of that transmission. A little piece of metal right here. There's a little chunk of something in aluminum right there. Get that cleaned out. See all the extra holding power of the trap door and the case all bolted together really hard. Nothing breaks. Bearing feels nice. Case over here, we got the self-aligning bowl over here, which is a little bit gritty, but it's probably got some grit in the oil, I bet. This one here obviously is working just fine. The little needle bearings are fine. Yeah, they move right around. No bushing wear or anything. See no evidence of issues with the case. I don't see anything. Nothing feels like it hit the case anywhere. I don't see anything that run your fingers through it. If you feel anything, you'll catch a peel of shard or something metal, and you'll see it. And there's nothing wrong with the case. So even though I broke the 2.5 teeth off the gears, well 3 if you count the other half. There's some issues. That looks like it's fine. Looks like I sleeved that. You can see how thick the tranny is. I welded this thing solid. See the extra metal on there. Filled it solid metal. Big ass bearing in here. Like I said, that's strong. Let's prove it again. I've gone through a couple of now without hurting anything. Keep that for later. So the oil pump's nice and free, so I didn't have any problem with the oil pump. The pump, that's nice and free. No issues at all. And the lifters. Down here. So I use cast iron lifter blocks off of a XLCH before 65 probably. So these are solid cast iron, so they don't wear. The aluminum ones wear a lot. They used to make bronze ones, so they were pretty good too. I haven't seen any of those in years, so I don't use those. There's my rag. I use Jim's lifters. Oh, these are big axle. I thought I was using a small axle. I don't like the big axle, but can't repair them. So normally these are chewed up pretty bad. So you can see there's metal, fine metal in there, but you can't feel any wear at all. There's no wear. You can't feel anything. It's nice and smooth. To clean this up, see if there's any wear in the block. The Tribune oil protects a lot of stuff. Really like it. So my springs are they're pushing 600 psi open. They're probably over 250 on the seat. Like I said, it runs 675 lift, so this thing goes way up in the lifter block. There's no screwing around in my lift. It goes all the way up in there. It goes right all the way. It goes up so high that I had to put double O-rings in here because it would hit the push rod cover and act like an oil pump oil out of it. So I got this seal here on top. There's also a O-ring seal underneath that, so it's double stacked. So the lifter actually goes up inside of the O-ring. You know, the top of this lifter, the O-ring has a radius cut. It actually goes up inside the O-ring. When I ran the quad seal all the way down, it would hit the quad seal and hit, because that's a rectangular shaped O-ring. So that's how much lift I got in this motor. Goes all the way up until it hits there. Alright, so those are all good.